Imagine this. Let's say you have a 3D scan of an object. You can either scan it yourself, or let's say you have created that 3D model using some sort of software. And what if you could have an algorithm by which you can just add some text prompt to that software or algorithm, and it generates stylized format of that 3D object that you give it as input? What would you do with that output? Well, you can always use a 3D printer to print that stylized model, or you can use the 3D asset inside a game and call it a different type of that object. Let's say a couch. You give that algorithm a 3D model of a couch, and you give some text input to that algorithm, and it generates a couch that looks different with some different styles. In this video series, I'll take you through such an algorithm that does exactly that, and the results will blow your mind. So let's begin. Alright, so the algorithm in question is called text-to-mesh. So text-driven neural stylization for meshes. So basically the idea is that you feed that neural network a 3D mesh file in .obj format, and you give the algorithm some text prompt, and it will generate some stylized version of that 3D mesh. Here some examples on their webpage, but we will use one .obj file of our own so that we can experiment with it a little bit better. So if you click on code, you will be able to see their GitHub page, and the setup is absolutely simple. So let's go through installing the text-to-mesh project. First thing you have to do is git clone the project. So I'll actually do it in desktop. So let's do git clone here. It should take a few minutes to complete because there are a lot of files in there. Alright, so now that our project has been cloned, let's go inside text-to-mesh, and you will be able to see this YAML file. So YAML file has the description of the dependencies that we want to install, and the one dependency that I want to draw attention to is clip. So just like most other text-based stylization algorithms, it uses a clip model, and for our experiments we will use this clip VIT B32 multilingual V1 model because it's easier to implement, and the best part about clip model is that it generates encoding for both text and images at the same time in the same encoding space, which means you can look up images just by searching for some text. So it makes the connection between text and images, which is a really useful tool for this project. And what you want to do with this is you just want to run conda env create -- file, which will create the text-to-mesh environment for you, and install all the dependencies in that environment, and then we can just conda activate text-to-mesh to get into that environment. So that should take a few minutes to complete. Alright, so I have already installed the whole thing, so I'm gonna cancel this installation. In fact, I didn't even need to git clone the project because I have forked the project, and I'll explain at the end of this video why I have forked it, because I added a little bit of code to fix some problems, especially the textures that it doesn't generate. But let's talk about it towards the end. Alright, so what I've done after forking is that I have added this Python file texture.py, which we'll look at towards the end of the video, and I will upload this this fork on GitHub so that you can download it and work on it as well. I have downloaded the paper here as well, and we will go over the paper in the next video, because who does experiment without reading the paper, right? So we will look into it in the next video, but for today's video we will just have some fun with the algorithm. So first thing you have to do is we need to download some .obj file or 3D mesh file, and to do that I am using poly.cam, which is a really good application. Actually, I use the app Polycam on my iPhone, and it runs pretty well. You can scan a 3D object and generate a 3D mesh by using RGB images, which is really cool. Another best thing about Polycam is that they have this nice website. You can go into the Explore and you will have some open source project here, or open source mesh that you can use for your project. And look for this folder icon. Unless it has this folder icon, you cannot import it to your personal account. But what I have done is I have imported some 3D mesh files for my experiments. So I have downloaded this building which has a bed, a cabinet, a shoe rack, and a chair in it. So that is something we will be looking at today. And also I have downloaded this couch for the experiments for today. And what you need to do now is that you gotta open it on Polycam. You have to export it. And if you're using the free version of Polycam, you can only download files in GLTF format. Ideally, you should use OBJ format for text to mesh, but if you're using a free version, you cannot download the OBJ format. But worry not, we will use Blender to convert the GLTF file into .obj format. So just start download. And once it has been downloaded, just copy this glbf file into whatever directory you want to keep it in, and then open Blender. Select General, remove the cube, and then import in .glb or .gltf format. For me, it's sitting in downloads, so I'm gonna load this file, and it should look like this. So a nice looking couch. You can check the textures here by clicking on this option, and that's how it looks like now. So what we want to do is to export it in .obj format. So click on export, choose wavefront.obj, and select your directory. For me, I'm keeping everything in the text to mesh fork that I have created. Inside data, you will find source meshes, and you can keep it there. I have created a .obj file called couch.obj. Another thing I did before exporting it in my directory, the source mesh directory, is that I removed this sort of carpet or floor. So if you want to do that, that is also easy. Choose this option and you will be able to see the points here. Choose edit mode, and now you can remove these extra stuff that you don't need. So if you do delete vertices, it will remove that portion of your couch. So that is something you can do because I just wanted the couch to be part of my experiments. All right, now that we have the couch inside our data source meshes and we have couch obj, you will also once you export the glb file into obj format from Blender, you will get a .mdl file, which is the texture of that 3D mesh. So for now we don't need it, but we will use it later for a comparison. We might but yeah, let's see what else do you have to do. So if you scroll down, it says you can run the below shell script to generate example styles. So let's look at the demo. So if you choose any shell script from the demo folder, you will see that they have the Python script that you can use to run the code. And if you look at the main file that it runs, which is here, python main.py, inside all the shell script, if you look at the main.py, you will see that it takes a ton of arguments. There is a lot of them, and it will be clearer the purpose of most of these arguments once we cover the paper in the next video. But for now, let's just take this demo as our base and run it on the couch that we sort of exported from Blender. So if you copy paste the whole thing into the terminal, and of course it gives me some error because I forgot to activate the environment. Okay, so now we have to change the arguments to match our input. So we are not giving it the vase, we are giving it the couch. So let's give it couch as input, couch, and let's call it cactus, and give it a prompt, an image of a vase made of wicker. So let's change the prompt. Let's say a 3D model of a couch made of cactus in Unreal Engine. In case you're wondering why Unreal Engine, how did it come to me? What I did is I opened a demo, and it has a script similar to this. It's called run_ninja, and it has a prompt, 3D rendering of a ninja in Unreal Engine. So again, engineering the prompts are a little bit of a skill that you have to master over some practice. So let's stick to it for now and let it run. Alright, so right off the bat, we have a problem here. If you try to run your code on a custom 3D object, it actually fails. And it says the size of a tensor 82,000 must match the size of a tensor B. And it's because when it samples the mesh vertices, the size doesn't match for the mathematical operation, the addition, especially because we are doing the matrix addition, which is where the problem starts. And to solve that, we have this solution. So it says, texture mesh learns to produce color and displacement over the input mesh vertices. The mesh triangulation effectively defines the resolution for this stylization. Therefore, it is important that the mesh triangles are small enough such that they can accurately portray the color and displacement. The mesh contains large triangles and stylization will not contain sufficient resolution. So that is a problem. But what I have found in my experiments is that this statement is not absolutely true. And I'll show you why later part of this video. But for now, what they are saying that if you run into this kind of tensor size mismatch issue, first you should run this remesh.py Python code to solve that problem. So if we look inside that code quickly, it's a pretty small file. What it does is that it calls something called PyMeshLab, which is a Python API to play with mesh files, and it creates this isotropic meshing, which what it means is that it creates triangles over the mesh files which are equal in size. So that's sort of what is needed to run this algorithm. So we will go with it and we will run this code. So let's do that. So let's clear this and we will run remesh, but our code, our obj file is sitting inside data source meshes and it's called couch.obj, and I want my output in the same location. And I can call it couch minus remesh.obj, and that is sort of what's is set as default as well. So that's good. So what I can do is I can run this code and it will generate a new couch file for me. So now you should be able to see that my data has a new file called couch remeshed. Initially I generated a couch remesh, which is why it's there. Now I generated couch remeshed, and you can also see that it generated the MTL file as well, which is the texture data. And I'll talk about the difference between them in a while. But now let's try our code once again, and this time instead of couch.obj, let's try couch minus remeshed. And we want it inside cactus, and it says a 3D model of a couch made of cactus in Unreal Engine. I'm gonna add the word rendered in Unreal Engine, just to be a little bit more specific. And one thing you can see, and we will talk about it a little bit in depth in the next video, is that you will see that it has a lot of linear layers. And the best thing about this algorithm is that you don't need a pre-trained model, generative model to run text to mesh. and most of the textures, most of the features that are coming from the text and the 3D mesh files are actually coming from MLP, or a multi-layer perceptrons. So it's mostly linear layers, which is why it's really fast, especially given that it's giving a 3D mesh as an output. So we will have to wait for at least 10 to 15 minutes for it to give us the final output, and I'll see you then.